Hello dear friends, welcome back to MACSGATE. We are learning probability and statistics from engineering mathematics. And today's topic is conditional probability. And conditional probability is one of the important concepts. Okay, so what I try to do here is I start with some examples. Through examples, we try to understand the concept of conditional probability. Later on, I'll give you a proper definition for conditional probability, and we also understand the formula for conditional probability, and we try to solve problems using formula method also. Okay. Please mark your presence if you are attending. You can let me know whether my audio, video, everything is fine. Hopefully everything is working. So let me start with today's session, that is conditional probability. So before starting, let me ask you one simple question. A fair dice is rolled. That is a single fair dice. Fair dice means all the outcomes are equally likely, is rolled. Then what is the probability? Then find the probability. That is missing, I am sorry. Find the probability that the number which is obtained is divisible by 3. So what is the question? What is the probability that when a fair dice is rolled, what is the probability that the number which is on the top of the dice is divisible by 3? Number is divisible by 3. So this is the question. So what is the answer for this, my dear friends? Very normal question. When a dice rolled, there are 6 possible outcomes. Out of that, how many are favorable for this divisible by 3? The outcome 3 and outcome 6 are favorable. These are the favorable outcomes. So 2 favorable out of 6. So what is the probability, my dear friends? It is 1 by 3. Okay. So what is the probability that the number is divisible by 3, my dear friends? It is 1 by 3. Now when a fair dice is rolled, the sample space, you all know, it is 1, 2, 3, 4, 5, 6. That is all possible outcomes. Now if I ask this question, what is the probability that the number is divisible by 3? See, what are the numbers which are divisible by 3, sir? 3, 6, 9, 12, 15, 18, like that you can say all the multiples of 3. Okay, there are infinitely many. But when I ask what is the probability that the number is divisible by 3, and when I ask what is the favorable or what are the outcomes which are favorable for this event, we only mentioned 3 and 6. Why we restricted? What restricted us to only 3 and 6? The sample space. What restricted us to 3 and 6? The sample space. So whenever you ask the question that what is the probability that the number is divisible by 3, the question is exactly same as probability that the number is divisible by 3 when sample space happened. This sample space happened. But we need not mention this because obviously here out of the 6 we are looking for the outcomes which are favorable for this number divisible by 3. We need not mention, but internally this is what you mean by probability that a number is divisible by 3. What is the inner meaning? Probability that the number is divisible by 3 when the dice is rolled or when the sample space happened. So sample space means 6 outcomes happened. Out of these 6 outcomes, how many are favorable for this event? 2 favorable for this event, and that is 1 by 3. So the idea is whenever you say probability of any event, the inner meaning is probability of the event when the sample space happened. So how you read it? Probability of A when or given sample space happened. But you need not mention that because that is by default. So that's why we don't write given sample space happened, because obviously when the die is rolled, then only we are looking for the outcome. So that is default. Am I clear? See, this point I want you to understand clearly and properly, because the conditional probability is based on this idea. Now look at this question. A pair dice is rolled, then find the probability that we get multiple of 3 when the number obtained is greater than 4. When the number obtained is greater than 4. So generally for this problem, I'll give you options. Okay. So I'll give you different options, like some people say, 1 by 6. Some people say 1 by 2. Some people have different options like 1 by 3, 2 by 3, something like this. They mention this. Now what is the correct answer for this? What is the probability that we get a multiple of 3 when the number greater than 4 happened? See here, this number greater than 4 happened, we need to mention compulsory, because when this happened, what is the probability of happening of this event? That is probability of what is happening now given what is already happened. So this is the story, my dear friends. See, this is happening now and this is already happened. This is already happening now. See, if you see the original problem, probability of any event is what is happening now, the event, and what is already happened, the sample space. So when it is sample space, there is no need of mentioning it. Obviously, when that particular random experiment happens, obviously all the outcomes are happening. But here we had some additional information. It is known that a number greater than 4 is happened. Now what is the probability that we get multiple of 3? See, please try to understand, this is very important. Always we find probability of an event given what is already happened. In general, what is already happened, sir? Sample space. That need not be mentioned. But here, what is already happened is number greater than 4. So this has to be mentioned. You cannot remove this. You cannot remove this. So what is your answer? If you are watching this, or later on if you are watching, you can try this question and write your answer, my dear friends. You can pause the video and write your answers. Because if you understand this concept, don't worry if you do mistakes, sir. Mistakes obviously happens in mathematics. We learn from mistakes. Even now I do mistakes, obviously. Don't worry about it. Try to write your answer on a piece of paper or in the comment box anywhere and check whether your answer is correct or not. Now tell me, what is already happened? A number greater than 4 happened when a dice is rolled. It's not dice is rolled, all the 6 outcomes are there. Dice rolled means 1, 2, 3, 4, 5, 6. But the number is greater than 4 means out of this sample space 1, 2, 3, 4, 5, 6. Okay, what is that? What are the outcomes favorable for number greater than 4? Only 5, 6. So here sample space is not happened. What is happened is 5, 6 happened. That is only 2 outcomes happened. Out of these 2 outcomes, how many are favorable for multiple of 3? How many are favorable for multiple of 3? Out of these 2 outcomes, how many are favorable for multiple of 3? Only 1. So 1 favorable out of 2. This is called conditional probability. This is called conditional probability. Hope you understand, my dear friends. This is called conditional probability. Probability of event A given event B already happened. Probability of happening of A when B has already happened. See, most of the student gives this answer which is wrong. Because here we don't have all the 6 outcomes already happened. Only 2 happened. It is clearly mentioned that number is greater than 4 happened. Then what is the probability that you get multiple of 3? So when this happened, what is the probability for this event? So this is called conditional probability. A given B. The general one is See, general one is probability of A for any event means probability of A given S, but that need not be mentioned if it is sample space. If it is not sample space, we need to mention this. And this probability we need to see for this how many favorable cases are there. Out of that favorable cases, how many are favorable for this event we need to check. If you are listing all the outcomes, then this is the methodology, my dear friends. Is the idea clear? And this is what we call it as conditional probability of A when B has already happened. Is the idea clear? So let us take some more examples. Of course, here only 5, 6 happened. If you observe, only what is happened, sir? Only 5, 6 happened. Out of 5, 6, how many are favorable for this multiple of 3? Only 1 is favorable. So the probability is 1 by 2. That is only this is favorable. Is the idea clear? Like next question. What is the probability of multiple of 3 when the number is greater than 1? See, number is greater than 1 means only these 5 numbers happened. So this is what is happened. That is these 5 outcomes happened. When this happened, what is the probability of getting multiple of 3? So how many are favorable for multiple of 3, sir? These 2 are favorable because 3 and 6 are favorable. These are the favorable cases. So 2 favorable out of 5. Multiple of 3. Now what is happened, sir? Multiple of 3 happened. Multiple of 3 means 3, 6 happened. So this is your event B. That is what is already happened is only 3, 6. That is only 2 events or 2 outcomes, not events, sorry. Only 2 outcomes happened. Out of 2 outcomes, how many are favorable for number greater than 4? Number greater than 4, only 1 fellow is favorable. 1 out of 2. So what is the probability? 1 out of 2. Is the idea clear? The next one. Now, multiple of 3 happened. That is 2 outcomes happened. Out of which, how many are greater than 1? Both are, I think both are greater than 1. 3 is also greater than 1. Sorry for that. I think a wrong animation. Both are favorable. Actually, both are favorable. 2 by 2. So the answer is 1. Sorry for the wrong animation. It happens sometimes. Is the idea clear? Both are favorable for, number greater than 1. Clear? Now look at this. Multiple of 3 happened. That is 3, 6 happened. Now out of these 2, which one is favorable for Rajnikant happening? See, by rolling dice or throwing coins or tossing coins, we don't get Rajnikant. Please note that. So what happens? There is nothing favorable for Rajnikant. So 0 by 2. So what is, I'm sorry, this animation, wrong animation, sir. The same animation continued. Sorry for that. So what is the answer? 0 for this. This is wrong animation. Please, sorry for that. Is that clear? Now this is very important. Now this is very, very important. Okay. Let me just clear this wrong animations because they are troubling us. Yeah, this time I think we don't have any animation. So happy for that. Right. Now look here. What is probability that we get multiple of 3 when Rajnikant happened? See, Rajnikant happening is impossible event. Am I clear? Impossible event. So whenever you are looking for probability of A given B, this B, that is what is already happened, must be a possible event. Suppose if B is impossible event, then this is not defined. So we cannot have this probability of A given B for every B. Probability of A given B is defined only for possible events B, only when probability of B is not 0. If B is impossible event, then probability of A given B, don't say 0, sir. It is not defined. We can't define it. So that question is wrong. Am I clear? Don't always think that every question is possible. These are all, wrong understandings. Am I clear? If it is only event, you can say possible or impossible. But whenever you are talking about A, when B is already happened, what is already happened must be a possible event. Then only we can talk about this event happening or not. Please note that. So this B must be possible event. B, not is, must be. B must be possible event. Hope you understand. Please note this point. So this is not defined. Don't say 0, sir. Some people write 0 answer for this. It is not defined. It is not defined. Okay, please note that. So we can extend this idea. Okay, initially I am solving all the problems by the conceptual idea. That is, we are trying to see outcomes. From that we are trying to answer this conditional probability. Okay, later on we also try to develop a formula for conditional probability, and we can use formula method also to solve the problems. Of course, for such basic level problems, direct method is better than formula method. I also show formula method for some of these problems, but for basic level problems, direct approach is much better. Please try to understand. A fair dice is thrown twice. So we rolled a dice 2 times. Sum of numbers appearing is observed. So some of the numbers you all know this. Okay. What are the possible sums, sir? 2, 3 up to 12. What is the probability that the number 3 appeared at least once when the sum is 7? See, suppose if I ask this question like, what is the probability that the number 3 appeared at least once? If I ask number 3 appeared at least once, total possibilities are how many, sir? There are 36 possibilities. Out of that, in how many cases number 3 appears, sir? See, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then 1, 3, 2, 3, 3, 3, 4, 4, 3, 5, 3, 6, 3 also it appears. But there is some 3, 3 which appears here and there twice. So 11 cases favorable. This is direct one. If you are directly asked, number 3 appeared at least once. So you can say 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then it is also like, 1, 3, 2, 3. And 3, 3 already repeated, so I am not writing 4, 3, 5, 3 and 6, 3. So these are the cases. So totally 11 cases favorable. But here it is not number 3 appeared at least one when the sample space happened. When sum is equal to 7 happened. See, we know for different sums what are the favorable cases. For sum 2 it is 1. If you remember, from 2 to 12 we are having cases like for 2 it is 1, for 3 it is 2, for 4 it is 3, for 5 it is 4, for 6 it is 5, for 7 it is 6 favorable cases, for 8 it is 5 and so on. So here for sum 7, how many cases are favorable? 6 cases are favorable. And what are the 6 cases, sir? Sum 7, how you can get sum 7, my dear friends? Sum 7, how can you get it, sir? 1, 6, yeah, 6, 1, 2, 5, yeah, 5, 2, 3, 4, yeah, to 4, 3. So these are the 6 cases. Out of these 6 cases, how many are favorable for this? So here this is happened. That is not 36 outcomes happened. Only these 6 outcomes happened. When these 6 outcomes happened, what is the probability that number 3 appeared at least once? What is the probability that number 3 appeared at least once? These 2 cases. 2 cases favorable out of 6. So what is the answer? 1 by 3. See, please note, conditional probability is not difficult. People make it difficult by applying different logics. See, always remember, probability of any event means probability of the event given sample space. But when it is sample space, we need not mention that. But if it is probability of an event when another event already happened, then what is already happened becomes your sample space. Out of that sample space, how many are favorable for this event? You have to look for that. If you understand this logic, this direct methodology for solving conditional probability is very, very simple, my dear friends. Next one. A fair dice is thrown twice. The sum of the numbers appearing is observed. Okay, very good. What is the probability that the number 5 appeared at least once when sum is equal to 7? So when sum is equal to 7 means 6 cases favorable. Number 5 appeared at least once. That is 2, 5, 5, 2. You already seen here 2, 5, 5, 2. So 2 favorable out of 6. That is 1 by 3 is the answer. Is the idea clear, sir? Sum is 4. This time here sum is 4. How many favorable for sum is equal to 4, sir? Only 3 cases favorable for sum is equal to 4. For sum is equal to 4, only 3 cases favorable. What are the 3 cases? 1, 3, 3, 1 and 2, 2. So 3 cases favorable, total possibilities. Out of these 3, in how many cases number 2 appeared at least once? This is the only case. So the answer is 1 by 3. So the answer is 1 by 3. Hope you understand. Is the idea clear? Right? You can try different problems, sir. You can take any sum because there are sums possible. What, sir? 2 to 12. Any sums you can take. You can take sum is equal to say 10 or 8. Let us take sum is equal to 8. Sum is equal to 8 and say that 2 appeared at least once. 2 appeared at least once. So sum is equal to 8 means 5 cases favorable. In that, how many cases are favorable for 2 at least once? 2, 6, yeah, 6, 2. 2, 6, yeah, 6, 2. 2 cases favorable. So 2 by 5 is the answer. Is the idea clear? Now this is very important, interesting problem, sir. This was asked in GATE. Okay, I might not mention that year and everything, but this was the question which was asked in GATE. A pair of dice rolled. Find the probability of getting a sum of 7 when it is known that the number on the first dice is greater than that of second dice. See, actually in the conditional probability, most common mistake which people do is when you are writing, for example, when you are writing probability of A given B, so you should identify what is happening now, what is happened already, or what is already happened. So this identification is very important, and even in that people do mistakes. If you can do this properly, if you can identify this properly, then you never do mistakes in solving conditional probability problems. The conditional probability problems you are going to use even in multiplication theorem. Even Bayes theorem is based on this idea only. The entire Bayes theorem is based on this idea only. Am I clear? So from here till the end of Bayes theorem, the story is same. What is happening now, what is already happened. Story is the same. Okay. So you may be seeing different situations when it is Bayes theorem. You may be worried about future probabilities. We'll discuss that, but you need to understand this. Okay. So fixing or properly identifying what is already happened and what is happening now. Sometimes people do reverse. Okay. They misunderstand the problem. Am I clear? You need to read carefully, my dear friends. Here what is mentioned? What is probability of getting sum is equal to 7 when it is known that number on first die is greater than number on the second die? Sometimes the same question can be asked like that. It is given that the outcome on the first die is greater than that of outcome on the second dice. So the same problem can be asked like that. It is given that, okay, the number on first dice is greater than number on second dice. So he stops a statement here. Then he asks, then what is the probability of getting sum of 7, getting a sum of 7? See, the same question can be asked like this also. The same question can be asked like this also. Then you are in trouble. And some people, they ignore this entire statement. They only find probability of getting sum 7 also. Some people only find what is probability of getting sum is equal to 7. 6 by 36, 1 by 6 they write. That option also may be available in the multiple choice. Please be careful. Read carefully. So here, if you assume x1 is outcome on the first die or number on first die, and x2 is number on second dice, what is already happened is x1 greater than x2 already happened. What is already happened, sir? x1 greater than x2 already happened. If you remember, when two dice are rolled, let me remove this right numbers, then I'll write it. Okay, when two dice are rolled, what are the possible outcomes, sir? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Then it is 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Continuing this way, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. Now if you observe, these are the cases. Okay, sorry. So these are the 36 outcomes, and if you observe, these are the 6 cases where you are having x1 is equal to x2. So for x1 is equal to x2, how many cases are favorable? 6 cases are favorable. Now if you observe this, above this, here 1 2, 1 is less than 2, 1 3, 1 is less than 3. So these are the cases where x1 is less than x2. How many cases favorable for x1 less than x2, sir? 15 cases favorable. Then in the problem, what is asked? x1 greater than x2, how many cases are favorable? For x1 greater than x2, how many cases are favorable, sir? 15 cases are favorable. So what is happened here is the 15 cases. What is happened here is 15 cases. Am I clear? So what is the probability of getting sum is equal to 7 when x1 greater than x2 already happened? That is outcome on first die greater than outcome on second dice. So here 15 outcomes happened. Out of the 15 outcomes, how many are favorable for giving you sum is equal to 7? See, my dear friends, normally you know for sum is equal to 7, how many cases are favorable? For sum is equal to 7, when two dice are rolled, sum is equal to 7, 6 cases are favorable. So whenever it is 6 even number, half of them are favorable for x1 greater than x2 and half of them are favorable for x1 less than x2. For example, if you see 7, okay, 6 1, 5 2, 3 4, and here 1 6, 2 5 and 4 3. See, you see half of them, that is out of 6, half of them are favorable for x1 greater than x2 and half of them are favorable for x1 less than x2 if it is even number. If the favorable cases for the sum is even, half of them are favorable for less than case and half of them are favorable for greater than case. So here how many are favorable for sum is equal to 7? Out of this 6, out of this 15, 3 cases. These are the favorable cases because x1 greater than x2 happened. Then for sum is equal to 6, or sorry, sum is equal to 7, we don't have 6 favorable cases, sir. Only 3 favorable cases. Only we are having 3 favorable cases. 3 out of 15. So what is the answer, my dear friends? 1 upon 5. 5. समझ में आया है? Very good. You can generalize this. Same here, x1 less than x2 happened, that is 15 cases happened. Sum is equal to 5. Normally for sum is equal to 5, when the sample space, when 2 dice are rolled, sum is equal to 5, how many cases are favorable, sir? Normally 4 cases are favorable, out of which 2 are favorable for x1 greater than x2 and 2 are favorable for x1 less than x2. So we want x1 less than x2, how many are favorable? 2 cases favorable out of 15. So directly you can answer. Sum is equal to 6 when x1 is less than x2. Sum is equal to 6, how many cases are favorable, sir? Normally 5 cases are favorable. 5. So in that 2 are favorable for x1 less than x2, 2 are favorable for x1 greater than x2, and 1 is favorable for x1 is equal to x2. That is 3 is there, no? That is favorable. So here x1 less than x2 happened means 15 cases happened. Out of the 15, how many are favorable for sum is equal to 6? For x1 less than x2, sum is equal to 6. 2 favorable cases are there. 2 out of 15. Am I clear? 2 cases favorable. See, actually, if I ask, like, what about sum is equal to 6 when x1 is less than or equal to x2? Suppose if I ask my question like this, x1 less than or equal to x2 means x1 less than x2 15 cases, x1 equal to x2 6 cases, total 21 cases. Out of 21, how many are favorable for sum is equal to 6? See, here either less than or equal to happening, that is only these 2 cases, that is 2 plus 1. So favorable cases are 2 plus 1, which is 3. In this case, 3 cases favorable. So what is the answer? 1 by 7, my dear friends. What is the answer? 1 by 7. Hope you understand. Is the idea clear? Next one. Sum is equal to 4 when x1 is greater than or equal to x2. x1 greater than or equal to x2 means how many cases favorable, sir? For x1 greater than or equal to x2, 15 for x1 greater than x2, 6 for x1 equal to x2, 21 cases. Now for sum is equal to 4, normally sum is equal to 4, how many cases are favorable? 3 cases are favorable. Okay, out of 3, 1 is favorable for x1 less than x2, 1 is favorable for x1 greater than x2, and 1 is favorable for x1 equal to x2. That is 2 case, sir. Okay. So here you can see 1 3 case here and 3 1 case here. So you want greater than or equal to means these 2 cases are favorable. These 2 cases. So favorable cases for sum is equal to 4 when x1 greater than or equal to x2 happened is 2 cases. So x1 greater than or equal to x2 means 21 outcomes happened. Out of 21, how many are favorable for sum is equal to 4? 2 are favorable. So what is the answer, sir? 2 upon 21. 2 upon 21. Is the idea clear? So the next problem, sir. A fair coin is tossed 3 times in succession. That is, you toss the same coin 3 times. Read the question carefully. If the first toss produces a head, then probability of getting 2 heads in 3 tosses. See, as I told you, sometimes people don't read the question carefully. So whenever question is asked, they directly go to the place probability. Probability of getting exactly 2 heads in 3 tosses. So they only read this much. They only read this much. Probability of getting exactly 2 heads in 3 tosses. So if you only read this, when 3 coins are tossed, I'm telling you the wrong solution, which most of the people do it. 3 coins are tossed, coin 1, coin 2, coin 3, 2 cases favorable, heads or tails on first coin. For each of these 2 cases, there are 2 possibilities on the second die. And for each of these 2 into 2 possibilities on the first 2 coins, there are 2 possibilities on the third coin. So total it is 2 cube, which is 8 possibilities. So when 3 coins are tossed, there are total 8 outcomes possible. Out of these 8 outcomes, so as I told you, people read it wrongly, like, probability of getting 2 heads and 1 tail. 2 heads and 1 tail. So what actually happens when 3 coins are tossed? You can write down all the 8 outcomes, sir. You can start from the last column, like, head, tail, head, tail, head, tail, head, tail. Double the number of heads and double the number of tails. 2 heads, 2 tails, 2 heads, 2 tails. Again, double the number of heads and double the number of tails. 4 heads and 4 tails. So these are the 8 outcomes, out of which 2 heads and 1 tail means 1, 2 and 3. So 3 cases favorable. So they go for the answer 3 by 8, and unfortunately the 3 by 8 is also option available. 3 by 8 option is also available in the answers. But Is it correct? It is not correct because they haven't read the question properly. What they read is probability of getting exactly 2 heads in 3 tosses. But actually, what is the question? If the first toss produces a head, then what is the probability of getting exactly 2 heads and 1 tails? So here, what is happened, sir? First toss is head. When first toss is head, then what is the probability of getting 2 heads and 1 tail? This is the question. It is a conditional probability question, but people done it wrongly. This is what people done, which is wrong. Please be careful. So here, when you are having 8 outcomes, like head, tail, head, tail, head, tail, head, tail, 2 heads, 2 tails, 2 heads, 2 tails, and again 4 heads and 4 tails. Actually, here we not have all the 8 outcomes happening, sir. When the first toss is head, when the first toss is head means what, sir? When the first toss is head means what? Only these 4 cases happened. So how many cases happened, sir? Only 4 cases happened here. Out of these 4 cases, how many are favorable for 2 heads and 1 tail? 2 heads and 1 tail, only 2 cases are favorable. So what is the probability here, sir? 1 by 2. So what is the probability here? It is 1 by 2. So please read the question carefully. See, as I told you, in conditional probability, the most common mistake is reading the question wrongly. Sometimes people read the question correctly, they understand it is conditional probability, but instead of writing A given B, they may write B given A also. That is another blunder mistake which people very, very commonly do. If you don't read the question carefully, यही होता है. So आपको क्वेश्चन को ठीक से पढ़ना पड़ता है. So you need to read the question very, very carefully. Hope you understand. So that is the idea, my dear friends. Okay, hope you understand what is conditional probability. Now I am going to introduce the notation for conditional probability, and I am going to give you the proper formula for finding conditional probability. So what is the notation for conditional probability, sir? We write probability of A given B. And how you read it? A given B. You also read it like, A given B, or probability of A when B also you can read it. So what is actual meaning, Babu? Probability of happening of A when B has already happened. What is it? Probability of happening of A when B has already happened. So please note, whenever you are talking about conditional probability, please make a note of it. What is happening now and what is already happened. Please try to understand this properly. So this is very important. So that is how we read conditional probability. Probability of A when B has already happened. In short, A when B, or probability of A given B. That is how we read it. Okay. And whenever it is normal probability of an event, the actual meaning is probability of A given sample space. But this need not be mentioned. It is default. But when it is any other event, it has to be mentioned, and we call it as conditional probability. Actually, probability of any event also can be seen as conditional probability only. Conditional probability that sample space has already happened. That's it. Okay. So everything is conditional probability only. But when it is sample space, we don't consider it separately. It is taken as default. So we don't mention it like that. Please try to understand. So, what is formula for finding conditional probability? what is the definition? You can call it as definition for conditional probability. Okay, probability of A given B. See, actually, see, when you say probability of A given B, so here what is already happened? B is already happened. So, see, if you see what is probabilities are favorable cases by total cases. So, probability is generally favorable by total cases. So, favorable here is what? What is favorable for B? That is number of outcomes favorable for B. Now, favorable for A, we don't write all the favorable outcomes for A. Favorable outcomes for A when B has already happened. So, here the number of outcomes which are favorable for both A and B. Number of outcomes which are favorable for both A and B. So, what is probability of A given B, sir? Number of elements in A intersection B by number of elements in B. Actually, this is how we are solving problems so far. But if you want to convert into probability formulas, what I do is, I just rewrite this like, you know, A intersection B, number of elements in A intersection B by number of elements in sample space, and number of elements in B divided by number of elements in sample space. I am just dividing numerator and denominator by sample space, number of elements in sample space, which gives me probability of A intersection B by probability of B. So that is exactly what happened here, my dear friends. Okay, so that is how we get this definition. Probability of A given B is probability of A intersection B by probability of B. Actually, you can say number of elements in A intersection B by number of elements in B. That is also absolutely fine, sir. From that only you get this formula. But when you are writing probability of B, because denominator cannot be 0, that's why B should be possible event. B should be possible event. That is very, very important. And of course, we just need to understand, sir, A given B can happen. Similarly, B when A is already happened also can be there. So what is probability of B when A is already happened? That is probability of A intersection B by probability of A. Here, A should be possible event. It cannot be impossible event. Please note that point. Am I clear? So this is the formula method, my dear friends, for finding conditional probability. This is the formula method. Okay. So what I do is, if you remember, we solved this problem earlier. Probability of getting multiple of 3 when the number is greater than 4. This was the first problem we solved on the conditional probability. So I take the same problem. Now I use the formula method for this. I try to use the formula method for this. Am I clear? So here I call this A as event multiple of 3. See, here I am not talking about A given B, sir. I am just talking about event A, event B. Multiple of 3 means what, sir? 3, 6. I am talking about the entire sample space. When the dice is rolled, A is multiple of 3. Multiple of 3 means what? 3, 6. B is the event that we get a number greater than 4. That is 5, 6. Now you know the event A, you know event B. Then you can also find A intersection B. What is A intersection B? Common. 3, 6, 5, 6. Intersection is 6. Now, for the original problem, what is the sample space, sir? That is, when the dice is rolled, 6 outcomes are possible. So, number of elements in sample space is 6. So, here A is having 2 elements. So, number of elements in A is 2, number of elements in B is 2, and number of elements in A intersection B is 1. So, now I ask you, what is probability of A? What is probability of A? Which is 2 out of 6. That is, what is probability of multiple of 3? 2 out of 6 favorable. What is probability of number greater than 4? 2 out of 6 possible. What is probability of A intersection B? 1 out of 6 favorable. Now I am having these probabilities. Now my question is, what is probability of A given B? So what is the conditional probability definition, sir? Probability of A intersection B divided by probability of B. And what is probability of A intersection B, sir? 1 by 6. And what is probability of B, sir? 2 by 6. So when you simplify, you are going to get 1 by 2. So I solve the same problem using formula method. But if I ask, which method you follow if this question is asked. Of course, you know direct method is much better, because when number greater than 4 means 5, 6 happened, out of those two numbers, how many are greater than 3? How many are multiples of 3? Only 1. So direct method is much easier. So people say, sir, why this formula, sir, why this headache? Suppose here I clearly mentioned what is the event, okay, and what is what is the random experiment. I clearly mentioned what is random experiment, what is event A, what is event B. So everything looks so formal, okay, boring also. But suppose, okay, leave it. Okay, this is already done. Suppose I not mention anything, sir. 1 second, I think. Suppose I not mention anything, sir. Okay, here I not mentioned anything. So here you don't know what is the random experiment. You don't know what is the name of event A, what is the name of event B. I only given the probabilities like this. So my question is just given like this. Here the question is just given like this. Here the question is just given like this. Okay. In that case, what you are going to do? In this case, what you are going to do? So in this case, what you are going to do? So can you tell me what is the original random experiment? Can you tell me what is A event? What is event B? I don't know, only probabilities are given. So there is no other way except you have to use the formula method. So don't think that the formula method is useless, sir. We need it. We need formula method also. So what is probability of A given B, sir? Probability of A intersection B by probability of B. And what is probability of A intersection B? It is given as 1 by 6, and probability of B is 1 by 3. So that is nothing but 3 by 6, yani 1 by 2. Hope you understand. Is the idea clear? All of you able to follow? So this is the idea, my dear friends. So whenever the probabilities are only given, okay, you can't use direct method, sir. Direct method cannot be used because you don't know what is random experiment, you don't know what is event A, you don't know what is event B. Then you cannot solve it. If only probabilities are given, you can't use that method. Suppose if random experiment is clearly given, events are given, direct method you can follow. But this method is important. Now I can ask you some more questions. This is very important, the formula method. And I am going to solve some very, very important problems here, my dear friends. Generally, people ignore these questions, but these are very, very, very important. So I want all of you to understand. What is probability of B given A by formula method? I am telling you formula method. That is probability of A intersection B by probability of A. A intersection B is 1 by 6. 1 by 6, and probability of A is 1 by 3, which is nothing but 3 by 6, yani 1 by 2. Is the idea clear? Now what is probability of A complement given B? See here, please see carefully, sir. A given B, B given A, you can solve it. Now it is A complement. What is happening now? Complement of that, if you want to find it, this can be solved directly like 1 minus probability of A given B. Why, if you want, I'll tell you that also. Probability of A complement given B means what, sir? It is probability of A complement intersection B by probability of B. And what is A complement intersection B, sir? Suppose if you see this is the event A, this is the event B. See this one we call it as A complement intersection B, which is actually probability of A complement intersection B, na? Sorry. This is A complement intersection B, sir. That is A complement intersection B. So when you want, you can take from probability of B. If you remove A intersection B, you can get that. So what is it? This can be written as probability of B. That is from B. If you remove probability of A intersection B, you will get it. That is from B. If you remove this portion, you get this part by probability of B. which is nothing but probability of B by probability of B is 1, and this is probability of A intersection B by probability of B. So that is nothing but 1 minus probability of A given B. So whenever it is A complement given B, it is 1 minus probability of A given B. Am I clear, sir? Is the idea clear? All of you able to follow? Yes or no? Right? So please note that. So here I can directly write, because already I found what is probability of A given B, which is 1 by 2. So 1 minus 1 by 2, what is the answer for this? It is 1 by 2. Am I clear? Now what about probability of B complement given A? Even this is 1 minus probability of B given A. 1 minus probability of B given A. So which is, we already solved what is probability of B given A, 1 by 2. So 1 minus 1 by 2, which is 1 by 2. So if you are having different numbers here, obviously the entire story will change, sir. Okay, please note that. But this is very dangerous. The most common mistake which people do is probability of A given B complement, they write it as 1 minus probability of A given B, which is blunder. Please note, this is wrong. Okay, so let me explain the story here. So when you take event A, event B, what is this, sir? Actually, it is actually probability of A and B complement by probability of B complement. Probability of B complement. Okay. So here A and B complement means this one, A and B complement given probability of B complement. This has to be solved. There is no formula we can create, sir. We have to solve this problem. Please note, sir. Okay, this one, given probability of B complement. B complement means remaining story, except this remaining story. Am I clear? So here, for this we need first of all, what is probability of B complement? When you know probability of B complement is 1 minus probability of B, which is 1 minus 1 by 3, yani 2 by 3. Okay, then what is probability of A intersection B complement? What is probability of A and B complement? So for that you can use this method, sir. Okay, because you know probability of A is 1 by 3, then probability of A intersection B is 1 by 6. So what is this portion? 1 by 3 minus 1 by 6. 1 by 3 minus 1 by 6 is how much, sir? 1 by 6. Similarly, this is 1 by 3. So what is this portion? 1 by 3 minus 1 by 6, that is 1 by 6. Okay, so this inner portion is 2 by 3, then outer portion is 1 by 3. Am I clear? Is that correct? 3 by 6, sorry. I'm sorry, very sorry. Inner portion is 1 by 6 plus 1 by 6 plus 1 by 6 is 3 by 6. Yani 1 by 2 means outer portion is 1 by 2. So that is the idea, my dear friends. So what is probability of A intersection B complement? You can simply do it like, you know, probability of A minus probability of A intersection B, if you want formula method. What is probability of A, sir? 1 by 3. A intersection B is 1 by 6. So it is 1 by 6. Now you know probability of A intersection B complement, and you know what is probability of B complement. Therefore, you can find what is probability of A given B complement, which is A intersection B complement given probability of B complement. A intersection B complement is 1 by 6. Probability of B complement 2 by 3. So what is the answer? 1 by 6 into 3 by 2. So it is nothing but 1 by 4. So this probability you need to be very careful, sir. Be careful when the complement is given for denominator. Of course, you cannot call it as denominator. For simplicity, I am calling it. Okay, if the complement is given for what is already happened, it is a process. We need to follow method to get the formula, method to get the answer. So similarly, we can try this B given A complement. What about probability of B given A complement, which is probability of A complement intersection B given probability of A complement. Okay, so what is probability of A complement, Babu? 1 minus probability of A. It is 1 minus 1 by 3, yani 2 by 3. And what about probability of A complement intersection B? From total probability of B, if you remove probability of A intersection B, you are going to get it, which is nothing but 1 by 3 minus 1 by 6 yani 1 by 6. Is the idea clear? So what about probability of B given A complement, Babu, which is probability of A complement given B, which is 1 by 6, by probability of A complement, which is 2 by 3 yani 1 by 4. That is the answer. So this is how we find these probabilities, my dear friends. Am I clear? So this is about conditional probability. Okay, so please try these problems. Okay, maybe I take one more problem, then I'll give you homework. Please try this. If you are watching, you can try this. Okay, hopefully I'll complete this problem. Okay, and we call it a day. The next topic would be multiplication theorem. After multiplication theorem, of course, in multiplication theorem, I'll be introducing independent and dependent events. Then again, one more session completely devoted on problems on independent events and dependent events. Once you understand, then we move on to the Bayes theorem. Mostly 1 or 2 sessions we'll try to spend. If a lengthy class is there, then we can complete in 1 session. Otherwise, we take 2 sessions for Bayes theorem. Okay, so 2 more sessions for this multiplication theorem and independent dependent event problems. Then Bayes theorem. Bayes theorem we try to do in a more elaborate manner this time, because we are doing it for data science and artificial intelligence also, and that is very important. And the same thing you study as naive Bayes theorem or naive Bayes result or algorithm when you study your machine learning algorithm. Am I clear? So first let us complete this. A box contains 4 bad and 6 good tubes. Say they can be tubes or balls or whatever it is, sir. 4 are bad and 6 are good. 2 tubes are drawn together. So you taken 2 together. One of them tested and it is found to be good. One of them is found to be good. What is the probability that the other tube is also good? That is, first tube, second tube. Okay, so first tube is good. This is the event. 1 I call it as first tube is good. 2 as the event, second tube is good. Now the question is, what is the probability that one of them is tested and it is found to be good? So one of them I call it as first one. First one is found to be good. What is the probability that the second tube is also good? That is, when the first tube is found to be good, what is the probability that the second tube is also good? So initially we are having 4 bad and 6 good. So 1 good you removed. So when you remove 1 good, what is the new situation, Babu? What is the current situation of the box? 1 good is removed. So what happens? 1 good is removed means how many good remaining? Because it is not replaced, 5 good will be remaining and 4 bad are remaining. So first one is good means this is the current situation, Babu. In this, what is the probability of getting second one good? So what is the probability of drawing second one good now? 5 favorable out of 9. So what is the probability that the second tube is good here, sir? 5 by 9. You can also try this by, formula method, that is using conditional probability also. Let us try that. Okay. See here what is happened, 2 tubes are drawn. Okay. So when 2 tubes are drawn, suppose you call the event as first tube is good. First one is, that is first drawn tube is, I just call it as first tube is good. And B is the event that second tube is good. First tube is good and second tube is good. Okay. Now, if you observe what is happened here, you want probability of B given A. Probability that the second tube is good given that first tube is good. So according to that, what is the formula? Probability of A intersection B by probability of A. Probability of A intersection B by probability of A. See, A intersection B means what, sir? First and second tubes are good. First and second tubes are good. That is, two tubes which you drawn, both must be good. So what is probability that both are good, Babu? What is probability that both are good, Babu? Favorable will be, what about the favorable here? 2 drawn. Okay, 2 drawn means 10C2, that is total. 10C2 is total. When two tubes are drawn from 10 tubes, that is 10C2, that is the total. Now what about the favorable? 6 are good tube. From that you need to take 2 good tubes. That can be done in 6C2 ways. So for A intersection B, probability is 6C2 by 10C2. Now what about the probability of A? What about the probability of A? You draw one tube, that should be good. A means one tube is drawn, that must be good. Am I clear? First tube drawn is good. So what is probability of A here, sir? 6 by 10. So what is this probability, Babu? 6C2. 6C2 is nothing but 6 into 5 by 2 factorial, 10 into 9 by 2 factorial. 2 factorial, 2 factorial get cancelled. 5 2's here, 2 3's here, 3 3's here. So it is 1 by 3. So numerator is 1 by 3, denominator is 2 3's and 2 5's, 3 by 5. So what happened? This is 5 by 9. So even formula method also you can do it. Even formula method also you can do it. Is the idea clear? So directly you can do it, or using formula method you can do it. So this is about conditional probability. Of course, don't think that conditional probability is completed, sir. We just started conditional probability. Now comes multiplication theorem. More ideas and more doubts will be cleared once you do this, multiplication theorem also. Am I clear? And once you do Bayes theorem, more of this conditional probability concept will be clear. Actually, from here onwards till the end of Bayes theorem, entire thing is story of conditional probability only. Okay, it is just the beginning. Okay, story abhi baki hai. Am I clear? Like that. So please try this as homework, Babu. Homework problems. So those who are watching now or later, take these questions, solve it, and please write your answers in comment box. Please write your answers in comment box. So these are the homework problems, sir. Second one, third one. And this is one more homework, very interesting question. Even this I want you to try, homework problem. See, my dear friends, if someone try these questions and if you write in the comment box whether right or wrong, then I try to solve them in the class. Otherwise, these are all just homework and they are like lifetime